Determinants. To every square matrix A equal to Aij of order n, we can associate a real or a complex number called the determinant of A. Determinant of A actually stands for the value of the determinant. So if you consider a matrix of order 2, capital A is equal to A, B, C, D, then determinant of A is equal to A with parallel lines equal to A, B, C, D with a pair of parallel lines. We write it like that, but we read it as determinant of A. That is equal to AD minus BC. This is the value of the determinant. Now, supposing if you have to find out the determinant of a 3 by 3 matrix, how do you proceed? Let us see it here. Before you proceed, you need to understand the fact that if you expand along any row or any column, the value of the determinant is going to remain the same. But generally, how is it done? Generally, it is expanded along the first row, or expansion happens along the row or column which contains maximum number of zeros. I told you we can expand along any one row or any one column. So you may wonder whether the value will change. No, the value does not change. Let us illustrate that with an example now. Evaluate delta is equal to 1, 2, 4 minus 1, 3, 0, 4, 1, 2. Delta is also at another notation for the value of the determinant. So now expanding along the first row, we get, here you need to be very careful. When you expand along the first row, if you pick up the element 1, the corresponding row and column need to be forgotten, and the resultant 2 by 2 matrix have to be taken into consideration. Suppose if I expand along the first row, the next element is 2. So you will attach a negative sign there, or you will change the sign, and minus 2 times the column and the corresponding row need to be forgotten. So there you will be left with minus 1, 0, 4, 2. Then you have to expand it as you saw it in the 2 by 2 matrix. And the third element is 4, so the fourth column and the first row will be forgotten. You are left with minus 1, 3, 4, 1. Yes, now let us proceed. So this is equal to 1 times 6 minus 0 minus 2 times minus 2 minus 0 plus 4 times minus 1 minus 12. So it's time to simplify it and give out the result. So it is 6 plus 4 minus 52 equal to minus 42. Now let us expand along the third column, because that's the only column which has the 0 there. So it is delta is equal to 4 into, you need to forget about that column and the row in which it is there. So it is minus 1 minus 12 plus 0 times something plus 2 into 3 plus 2. On simplification, that also we get it to be minus 42. Thus we find that expanding along any row or any column will give the same result. Now you may expand along the second row and second column, or third row and the first column, and check out if there is any difference. You will notice that you will again end up with minus 40.